Hey guys, this is Martin and welcome to the cross-site scripting XSS bug hunting methodology. Let's jump right in. So first of all, the different types of cross-site scripting. The first one is reflected or reflective XSS. So that basically needs user interaction in order to fire or execute. So what I mean by that is it is not stored. Basically, you go, for example, to a search functionality or something, and you put your payload in, your cross-site scripting payload, and then you hit search, and then a pop-up window, for example, appears. So in order to replicate this for a user, you need to put this, to craft this link, for example, specifically for that user, so that the user then clicks it and the parameters are being embedded in that link, for example, or you need to lure the user to a specific website where you store your payload, which is then executing that cross-site scripting vulnerability on the target application. Okay, so that needs user interaction. That means you have to send a link to the user in order for this to trigger. Stored one is a lot more dangerous because in the stored one, you, for example, have a block comment or like a comment functionality or an input field, and you put it in there, and then it's stored in a database. And every time this is being retrieved, that info is being retrieved from the database, the victim gets that payload executed. And that's obviously a lot more dangerous because all the victim needs to do is to visit that specific website, like this blog post, for example. DOM XSS takes place in the document object model, and that's just local client-side vulnerability. So client-side JavaScript vulnerability, in other words, there is usually like a source and a sink. A source is a dangerous or user controllable input, and the sink is an insecure function or a dangerous function which takes that input and then executes it in the DOM, basically, right? So self-XSS it only affects you. Like think of a portal where you can change your profile information and you put it into your name field, but you fire the XSS, but it's only firing for you, no one else, right? That's self-XSS. And then blind XSS is it fires for someone else, but not for you typically. So in other words, for example, you put through a shopping order or a pizza delivery order or something, you put a cross-site scripting payload, you don't see the result, but the person who opens it on the other end will get their payload executed. And there is things out there like XSS Hunter where you can get the payloads for this for free. And then sometimes I had cases where a week later or even a month later, the payload fires in the context of an administrator or of someone in that company. Okay, let's move on. So the approach is basically test every parameter you come across. This is, it's a lot of work, but it is well worth it and it will pay off eventually. So test every parameter you come across, test every header value as well, right? And don't forget these blind things. Like if it doesn't fire for you right away, don't give up because it may fire for an administrator or a moderator or someone in that company who receives that specific message or browses to that page regularly, right? So blind XSS is very, very common. Discover hidden parameters. So you can use stuff like the paraminer on Burp to find hidden parameters which are not obvious from the web functionality, or maybe they have been forgotten, or maybe they're for future use, but they're already live and those kind of things, right? And then a classic test payload I always use is like the test, and then // angle bracket close, open, and then backtick, double quotes, quote, to see what is filtered, what is encoded, how the application takes that input, right? So sample payload you see here, like this is an SVG tag, onload, fire that alert, right? And typically for bug bounty hunting, this alert is fine, right? If you do pen testing, you want to do more. Usually you want to extract like a cookie, or you want to provide more impact, right? But for bug bounty hunting, typically the alert 0 as a POC is fine. And then also think about XSS in payloads like the name, like for example, name fields, files, users, etc. Right? Like I had cases where you basically can simply introduce an XSS payload as a file name, right, to a file which is then being executed on the other side. It's really funny sometimes. Like, think about all these different possibilities. It's not always the input form. Sometimes it's as simple as, like uploading a file and giving the file name instead of Martin123, give it the name of a cross-site scripting payload, right? Now, always look for parameter names and values and then check them both. So what I mean by that is, like, if you have, for example, a parameter called image, and then the image is called image123, checked in both, right? Yeah, like you can do this in burp, because sometimes the vulnerable or the vulnerability doesn't sit in the value, it sits in the actual parameter name, right? So I had those cases before as well. And then look for filters, right? Like, whenever there's a filter, there's a bypass. It's so easy for developers to fix cross-site scripting with input sanitization and the right output encoding. But if they create a filter, they may have something to hide, right? And filter is always a good sign that there is a bypass. Go to payload all the things, Google that term, and go to GitHub, and you find a ton of ready-to-go payloads from other security researchers. Then start with harmless payloads. Don't start with script tags and stuff like that. See how it behaves with an H2 tag or an image or a table tag or something like this. And then sometimes if you see like angle brackets are being encoded, doesn't mean to give up, right? So they're doing something right, but what if you double encode it? You might as well bypass that filter, right? So it's not always give up on the first try. There's always multiple routes to success. If you always see something like this, right? If you always see it is always encoded and no matter what I try, then it's likely not vulnerable. Move on to the next one. Move on to the next parameter. Sometimes you have good XSS filters in place, but don't give up on the first try, right? Also, reverse engineer the developer thoughts. Why they created a filter in the first place? Why they don't sanitize it properly? Or why they don't do the output encoding correctly? Why the need for a filter? Now, if they put a filter in here, chances are they put a filter on redirect parameters as well. So there may be SSRF vulnerabilities, CSRF vulnerabilities, open redirect vulnerabilities. So if you really analyze an application in depth, you will actually start to find, hey, there may be more problems than just XSS. So sometimes they might be filtering like the common keywords like script, iframe, on error, event handler, and stuff. Something you can try is a half-open script tag like this one shown. So this may break the JavaScript functionality, but it may execute your JavaScript. And sometimes filters are so configured that they are looking for complete script tags. And because there is no closing angle bracket in this one, it may as well bypass the filter. Things to test in general is like those kind of tags, like I explained, H2 script, half open script tags, or throw the script tags around with incorrect syntax. It may still see it as a script on the server side, but it may throw off the filter, and the filter or the WAF says, oh yeah, this is fine. This is not what I'm looking for. What I've also seen in the past is that they only filter like one instance of angle brackets. But if you put two instances, it filters the outer one, and then you have your script tag still left with the inner one, right? Like those are all kinds of things to try. Also test, like when you sign up with an email, can you actually put like an HTML tag or a script tag into an email address and stuff like that, right? Like sometimes this works and it's interesting when it's reflected back to you in the portal or wherever this is visible. Sometimes they only filter on lowercase. So what if you write iframe in uppercase? Perfectly legitimate from a coding perspective, but you might throw the filter. Or try non-standard event handlers like on XSS, for example, or go over to the Portswigger website to the XSS cheat sheet, and you have so many different event handlers. I had cases where they filtered statically 25 event handlers, but they didn't filter 2 of them, and I used them to exploit it. So is SVG blacklisted, for example? And then Another huge topic is how they handle encodings. Like, for example, if you put a nil byte in there, Unicode and stuff, then you might throw the filter off track, right? Like, so it's filtering the angle bracket iframe or the angle bracket or the on error, right? Event handler. But if I put a nil byte in there or a percentage 0D or like a tab or carriage return encoded, then I might throw the filter off track, right? And then, as I said, like very often it's just hard-coded strings they're filtering. So the first one I've already shown you in the last line, but the other one is a classic, right? Like uppercase, lowercase mixture may bypass the filters. So this is a summary of what we have just done, right? Like H2 tags, incomplete tags, and malformed tags, or like uppercase, lowercase variations. So here's a couple of other things on how to test encoding, like also in the H2 tags, you know, percentage 00, 0D, 0A, 09. Those are the most common ones. There's more. Try them all. You know, like I really had good success with the encodings. Understand the encodings first of all. What is HTML encoded? What is URL encoded? How does this look like? You can head over to Burp into the decoder and can just put them in and then encode them, double encode them, and then decode them and decode them again, and just familiarize yourself with encodings. Right? So I had loads of cases where encoding did not work, or single encoding did not work, but then double encoding, double URL encoding worked just fine, right? And this is just something to be aware of. Play with the encodings. There's so many bypasses when it comes to encodings. Now let's take a look at the DOM, right? The document object model. So whenever you hunt for cross-site scripting, you always should do three things. Number one, look at the source code, like inspect the page source, view page source. But also you have to inspect the DOM, right? Because one misconception out there is, hey, I already looked at the source code, I don't need to look at the DOM. Oh, yes, you do, because the DOM may have a lot more information, because it may often append stuff from AJAX calls, like when there's another web request being made in the background and it's pulling information in from somewhere. You see this in the DOM, but you do not see this in the view page source. So very important. And then thirdly, also analyze JavaScript files. You have to browse through JavaScript files and you look for certain things which may assist you in pulling off cross-site scripting vulnerabilities. Sign up with a payload, right? Like take a normal payload and then sign up with this in your name field, description field, things like that. As I mentioned earlier, DOM XSS is client-side only, so there's no server interaction. With the classic cross-site scripting, it's basically you're sending a payload up to the server and the server reflects it back to you or to the victim, or it stores it in a database and stuff. With DOM XSS, everything happens locally. So that means you have a sink and you have a source, and the source is the user controllable input, right? Like your payload. And the sink is a dangerous function or a dangerous functionality which processes your input. And then based on that, you can execute a cross-site scripting vulnerability because it's not sanitizing it properly. So that's DOM XSS. Now, JavaScript, you look for certain things, like the classic ones are document write, inner HTML. So just go through the code in Burp, look for certain keywords, right? I have a whole list for those, which I will provide to you like in a separate document. Look for JavaScript redirections. So whenever you see like a return URL, like a top location href return URL, well, instead of putting a URL in there, like first of all, analyze the function, but maybe I can put a JavaScript alert 0 and it fires, right? So if you look at JavaScript, look for variables, because sometimes they may be obvious or they may be seen in the browser requests and in the Burp requests, but sometimes they may be undefined, or what I mean by that is maybe there's functionality which is already been put to sleep and is no longer in use, or there's functionality which they haven't launched yet, like new features and stuff like that. Use the burp parameter as well, but also do your manual search in JavaScript files. Look for like input tags and stuff, right? Like parameters. Look for return URLs, like go to R URL, all these kind of things to find. Open redirect goes usually hand in hand with cross-site scripting, because very often you can use an open redirect to actually get a cross-site scripting execute. Now let's look at a couple of problems, right? Like, so from a researcher perspective, if this payload, if I'm using a standard payload and I see that the script tags are filtered, what do I try? Well, I try a half open script tag, right? Or I try a script which I load from a certain source, which you can then define, right? And like your web server or something. Use a non-real script tag or number as a script tag. Use like a non-real script tag and use like a very, very rare event handler. So again, on the Portswigger XSS cheat sheet, you find a lot of them, right? It's not always on alert and on error and on mouse over. There's so many of them, and sometimes they're only filtering on the ones they think are the most dangerous ones, whereas in fact all of them are dangerous. Okay, example 2a. This is basically, you see that it's reflecting your input as text, and that's not what you want, right? Like, what you want is your input shall be executed within the victim's context. It shall be executed as JavaScript, not presented as text on the website, right? So sometimes what I've seen, what works is URL encoded, and you may get a different result. It's actually executing it. If that doesn't work, WURL encoded. So you can see this here, looks very cryptic, super easy. You're just taking the tags and the slash in the original payload and either URL encode them once or WURL encode them. Very simple. Sometimes you see something like this reflected. Okay, so you put your script payload in and you get it encoded, and you think like, hey, they're doing something right here. They're actually encoding the output correctly. But once again, try URL encoding it. Try WURL encoding it. If URL encoding doesn't work, use HTML encoding, right? Use Unicode encoding. Like, you have so many different possibilities. And over time, you will get a feeling for it, like what works most of the time, what doesn't work, and those kind of things. So sometimes you see an interesting error, which is this, for example. So you only see a part of your payload reflected. And that's usually the case when your input field is limited in terms of characters. Like, let's say you have like a name field and it can only have like 25 characters. So you don't get the whole payload in there. So what can you do is you can basically submit this 3 times. Like, if it's like, say a block or something, you can submit it 3 times. Or if it's like a sign-up functionality, you can do this 3 times. And the first account or the first time would be like a script and then /*. So that means everything after the script tag will be a multi-line comment in JavaScript. So it will be ignored. So then you go to account 2 or to your second post, and then you put a */. So that means comment is finished now. So the code will be read as alert 0 again. Afterwards, you will start a multi-line comment again until you come with the third account or the third post, and then you put a */, and then you're finishing script tag. So the last one means read the closing script tag as code again. And I had this at least on 2 occasions that this worked, and I was able to actually execute cross-site scripting, even though my input was fairly limited in terms of characters. Another thing you might see is something like this, that, you know, like the brackets are being, the round brackets are being filtered and the angle brackets are being filtered and stuff like that. But the input is still being reflected like in an input value tag, right? So what to do, right? Like, if I can't introduce my own script tags, I may be able to use an event handler, right? And you see, I start all these payloads down there. I start them off with a double quote to break out of this input value field, right, to be free. And then I can put an on focus in on mouse over and my payload. And I had really, really good success with this. And it's just a trial and error, and you need to see how the application responds to it. But this is very often possible if your input lands within the value of like an input tag or something. Now, always try to create impact with cross-site scripting. I said earlier that you do actually not need to worry too much about cookie stealing when it comes to bug bounty. That's correct, right? So they will accept a cross-site scripting vulnerability, but you should still go a bit further and document in your report, hey, you only use you're not using HTTP only cookie attributes. So that means I can actually steal your cookies. So if you don't have the HTTP only set, that means JavaScript can actually read your cookies. And that would then help, for example, if you have a cross-site scripting vulnerability, and you don't need to demonstrate this, right, in bug bounty, but you do it, you put it in the write-up so they understand, because you could take over an account, an ATO, because any victim who visits that stored cross-site scripting vulnerability, I'm able to steal their cookie, and then I can log in as them, and then I have their account taken over. Another thing is, for example, very often you can combine cross-site scripting with CSRF. So you can use a cross-site scripting vulnerability and the script you can execute to actually perform a CSRF, a cross-site request forgery action against a victim, to then change their email address or whatever, right? So this is often chained together. You can often also leak sensitive information, like payment information may be just appended to the DOM. And if you have a cross-site scripting vulnerability, you basically can do the same thing as the victim user could do in their browser. So that's always important to keep in mind. You have the same control. And very often you can leak sensitive information. And you can also use cores in combination with cross-site scripting. So you use cross-site scripting in order to basically launch a core's AJAX request. But we come back to this in a bit when we talk about cores. Okay, thank you very much. That's the first chapter. I hope you learned something. We will now go through the Burp Labs, and I've prepared all the apprentice and all the practitioner labs for you to follow through with me and to get a better understanding how this is being exploited in practice. Thank you very much.